In this video, we are going to do part 2 of balancing chemical equations. Here I'm just going to do 3 examples of some beginner level chemical equations to balance. So as a recap from our last video, the tips are that we cannot spontaneously add an element. We cannot change the elements or the compounds that we have. Can't do that. And the only thing that we can do when we're balancing chemical equations is changing the number of each compound that we already have. So we did that in this example here. We just we calculated out, or we mapped out which elements that we have. So which individual elements we have. We have hydrogen, we have oxygen. And then we counted how many we have. And we kept changing these numbers inside of the chemical equation until we arrived at having the same number of each element on both sides of the equation. Boom. So that equation is balanced. Now we're going to do some more examples on balancing chemical equations. So here in this next example, we have sodium plus Cl2 gives us sodium chloride. And again, the only thing we can do is changing the numbers inside of these boxes. So let's go ahead and do that. And we are going to start every problem the same way, at least if you're doing it through my method, of calculating, writing down what elements we have. We have sodium and we have chlorine. Those are the only 2 elements we have going on here. And we have sodium and we have chlorine. It doesn't matter that this is sodium chloride. We're breaking it apart into its individual elements. So sodium and chlorine and sodium and chlorine. It's always going to be the same on both sides of the equation. Now we are going to count how many of each that we have. So I have 1 total sodium on the left side, so I'm going to write 1. I have 1 total sodium on the right side, so I'm going to write 1. I have 2 total chlorines on the left side, and that can be confusing to some people. They said, well, and that's because even though we have chlorine bonded to chlorine, it doesn't matter that there's a bond between them. We still have 2 chlorines. So we have chlorine bonded to chlorine. And it looks like this. But notice we still have 2 chlorines. So that's why I wrote down that we have 2 chlorines. So 2 chlorines on the left side, but on this other side, on this right side, we only have 1 chlorine. There's only 1 chlorine in sodium chloride. So 1 right there. So we can now see very clearly that our equation is not currently balanced. And we see what we can do in order to balance it. All right, so noticing that the chlorines are unbalanced, we're going to have to do something to the chlorines in order to balance them. We have 2 chlorines on the left side of the equation, but only 1 on the right side of the equation. So I'm going to have to add chlorines to the right side of the equation. I can do so by adding a number to the space before the elements on the right side of the equation. Since there's only 1 element on the right side, or compound on the right side of the equation, I only have 1 spot where I could potentially change the number for. So instead of 1 sodium chloride, if I need 2 chlorines, I can get 2 chlorines by having 2 sodium chlorides, because that means that we're going to have 2 NaCl's. This is how, I guess how you draw it. Cl minus. So I have sodium chloride. If I add another sodium chloride, that's what it's going to look like. Look, 2 total chlorines now. So 2 total chlorines. And whenever I write a number on one side of the equation, that entire side of the equation, I need to recalculate how many of each element that I have. So now I have 2 sodiums and 2 chlorines. So let's write that down. I have, instead of 1, I now have 2 sodiums. And I also have 2 chlorines. On the left side of the equation, let's now compare what we have on the right side of the equation to the left side of the equation. Chlorines are now balanced. So we are good to go with the chlorines. However, by balancing the chlorines, we ended up unbalancing the sodiums. So we need to figure out what we can do in order to balance these sodiums now. So sodium has, there's 2 on the right side, but only 1 on the left side. So we can get around that or fix that by adding 1 to the left side of the equation. So I add a sodium there. So now I have 2 total sodiums. And I get 2 total sodiums. And I'm going to recalculate, since I changed the number on the left side of the equation, I'm going to recalculate everything on the left side of the equation. I have 2 sodiums, and then just to double check, I still have 2 chlorines, so we're good. Now noticing that I have 2, I have the equation is balanced. I have 2 sodiums on both sides of the equation. I have 2 chlorines on both sides of the equation. We have now, double checked our work, and we got the question right, ready to move on. All right, next problem. We're going to start it the exact same way. We have sodium chloride and difluorine, creating sodium fluoride and dichlorine. Let's see how we can solve this. So we're going to start the same way. Write down what elements we have. We have sodium, we have chlorine, and we have fluorine. We have all of those elements on both sides of the equation. Even though we have fluorine written first here, I would encourage us to write it in the same order on both sides of the equation. It'll just be a little bit less confusing, a little bit easier to compare them. So write it down, whatever order you want to write them in, doesn't matter. Just be consistent. It'll help you out. So sodium, chlorine, and fluorine. Let's count how many of each that we have now. I have 1 sodium on this side of the equation, 1 chlorine, and 2 fluorines. Awesome. Now moving on to the product side, the right side of the equation. I have 1 sodium, 1 fluorine, it's over here, and I have 2 chlorines. Write that down right there. So as we can see here, our sodiums are balanced, but chlorines and fluorines are both unbalanced. We need to figure out what we can do in order to balance these both and to solve this question. So I can either try to balance the chlorines or the fluorines first. It does not matter at all in this question. I've given the tip before that if you see an element by itself not bonded to another different element, then it's good to save that one for last. But notice that that's the case for chlorine and fluorine, or fluorine and chlorine, so it doesn't matter which one we choose. I'm going to balance chlorine first because I wrote it down first, but there's no particular other reason or good reason that I'm doing chlorine instead of fluorine. It does not matter for this problem. So sodium's already balanced, so we're fine with that one. We don't want to mess with sodium if we don't have to. All right, but chlorine, we have 2 on the right side, but only 1 on the left side. So I can change the number of chlorines by doing one of 2 things. I can either write a different number here or a different number here. It's not going to help to write a different number here for chlorine because the only thing that this is attached to is fluorine. That's not going to change the number of chlorines. So we're going to have to change the number written right here. So if I need 2 chlorines, then I need to write a 2 here so that I have 2 chlorines. So let's write a 2 there and see what happens. So 2. And now let's recalculate everything on this side of the equation since I changed the number over here. So that 2, I have 2 sodiums now. I have 2 chlorines now. And the number of fluorines didn't change. It's still 2. All right. Now, comparing left side of the equation to right side of the equation, I have chlorines are now balanced. But sodiums are no longer balanced, and fluorines were never balanced. Let's go ahead and solve fluorines next. I would say that I would suggest kind of making a plan on what order you're going to solve things in at first, and then following that order. So we said we were going to do fluorine next, so let's do fluorine next. And for this problem, it actually won't matter because you're going to end up balancing both at the same time. So fluorine, I have 2 on the right side, but only 1 on the left, or sorry, I have 2 on the left side, but only 1 on the right side. So I can get around that by changing a number written either here or here. But right here, that's not going to help. That's only bonded, attached with chlorine. We want to change fluorine. So if I write a 2 here, though, 2, then now I have 2 sodiums and 2 fluorines. So let's write that down. I have 2 sodiums now and 2 fluorines. We're going to double check chlorine as well. Chlorine didn't change because we still have 2 chlorines. So now, comparing left side to the right side, we have the same number of every element on both sides of the equation. All right, last question. Pause the video and try to do this on your own, and then I'm going to quickly go through it as an answer for you. So pause the video and be back when you finish. All right, we have S8 plus O2 gives us SO3. Let's go about how we're going to solve this. So we're going to solve this the exact same way. Write down what we have. We have S and O. On that side of the equation, we have S and O on this side of the equation. So how many S's do I have? So how many sulfurs do I have? I have 8 on the left side of the equation. And I have, there's no number written here, so there's 1 sulfur on the right side of the equation. Oxygen, I have 2 oxygens on the left side of the equation, and I have 3 oxygens on the right side of the equation. So let's balance this all out. We might say, well, wait a second, which one is going to be easier to balance? I would say, how do I explain this? It's going to be a lot easier to balance the sulfur first. And I would just kind of look at it and see if something doesn't immediately balance, try to save that one for later and balance what's the easiest to balance first. So in this case, sulfur, it's going to be a lot easier to balance that one first because there's only 1 of it, and I can't add any oxygens here. I can't add oxygens here to balance this because there's already fewer oxygens on the left side. So I'm going to say definitely balance sulfur first here, and you'll get better at choosing which thing to balance first as you go. But sulfur, I need to write an 8 here, and then I get 8 sulfurs. And don't forget that this also is going to change the number of oxygens. I have 8 times 3. I have 24 oxygens now on the right side of the equation. So now sulfurs are now balanced, and we're going to move on to oxygens. Oxygen, we now have 24 oxygens on the right side of the equation and 2 on the left side of the equation. So very unbalanced right now. But what times 2 equals 24? We could say, well, 12 times 2 equals 24. And we'll say, now when we put a 12 there, we end up with 24 oxygens on both sides of the equation, 8 sulfurs on both sides of the equation. We have now finished that problem and got it right. So nice work. Hopefully those were helpful. We'll do some more example problems in our next video with a little bit harder examples.